Hi, hello, welcome back to my YouTube channel. So today I am going to discuss about F test for equality of population variances. This can be asked in the other way, testing the equality of two population variances. If they ask about two population variances, we have to write F test itself. Okay, so this is related to semester 4 in unit 3 small sample test. Okay, so if you want to test any testing, so first we need some samples. Okay, so now we'll see about that. So suppose we are interested to we are interested to test whether two normal population have same variance or not. Same variance or not. Okay, so if we want to test whether two population variances are equal or not, we have to use this test. Okay, that is nothing but F test for equality of population variances. So, and next is let x1 x2 and so on xn xn1 be a random sample of size n1 from the first population with variance sigma 1 square. Okay, why? Because we are going to test the population variance itself. That's why. So, n samples are having the variance sigma 1 square. Okay, and another sample we have to consider now, y1, y2 and so on yn2. Here n1, here n2. Okay, n2 be the sample of size n2. Okay, so this sample size is having the size n2 from the second normal population with variance sigma 2 square. Okay, so it is another population. We are taking from another population some samples and we are considering that sample is having variance sigma 2 square. Okay, so and the two samples are independent. They are not at all dependent. Why? Because we are taking from different populations. Okay, that's why they are not dependent. They are independent. And the two samples are independent. Okay, so now if we want to test anything, we have to follow the hypothesis testing procedure. That is nothing but first we have to set up null, alternative, level of significance, next test statistic and conclusion. So we have to follow those 5 steps. The first step is null hypothesis. So we have to consider first the null hypothesis. So what is null hypothesis? So our aim is to test the equality of population variances. So here what we consider is the population variances are equal. We have to think or else same. Okay, so null hypothesis, the two population variances are same, or else we can call it as equal. That is nothing but H naught such that sigma 1 square equals to sigma 2 square. Okay, this is about null hypothesis. Next, what is alternate? We have to think that the two population variances are not same. alternative hypothesis. So the next step is alternative hypothesis. So here we have to think the two population variances are not same. That is H1 such that alternative hypothesis denoted with H1. H1 such that sigma 1 square not equals to sigma 2 square. Okay, this is about what? Alternative hypothesis. So now what we have to do is test statistic. Okay, so test statistic. So under null hypothesis, the test statistic is nothing but F equals to S1 square by S2 square. That follows F distribution with n1 minus 1 comma n2 minus 1 degrees of freedom. Okay, when we have to use this formula? When S1 square greater than, S2 square greater than S1 square. Okay, so when S2 square is greater than S1 square, we have to use this formula. And next is where S1 square equals to 1 by n1 minus 1 summation I equals to 1 to n1 xi minus x bar whole square. In the same way, S2 square equals to 1 by n2 minus 1 summation I equals to 1 to n2 yi minus y bar whole square. Okay, so here the degrees of freedom is nothing but n1 minus 1, n2 minus 1 is the degrees of freedom. So here the condition is here S1 square should be greater than S2 square. So which is greater? It should be in what? Numerator. If S2 square is greater, we have to keep S2 in the numerator. Okay, this condition is wrong. So here S1 square, S2 square, we have written the formulas. Now conclusion. So here test statistic is nothing but what is the test statistic? Test statistic means degrees of freedom. Level of significance is degrees of freedom. Here the degrees of freedom is nothing but n1 minus 1 comma n2 minus 1 degrees of freedom. That is level of significance. Okay, so now conclusion. Okay, now conclusion. So the conclusion is nothing but if F calculated value is greater than or equal to tabulated value of F. Okay, so we conclude that null hypothesis null hypothesis rejected. Null hypothesis rejected. Why? Because here we have written the condition greater than or equals to. Actually, F calculated should be less than F table. So if the equals to, if the condition is like this, what we do is we accept. But we have written here greater than or equals to. Okay, here we have written that greater than or equals to. If F calculated is greater, then what we have to do is we have to reject null hypothesis. If it is in this form, we have to accept null hypothesis. So this is the conclusion. Okay, so if they ask about population variances, it is nothing but it comes under F test. Significance of F test procedure we have to write. Okay, equality of two populations if they give, or else if they give population variances, the same procedure you have to write. That means it comes under F test. Okay, so this is about today's class. So thank you for watching this video. If you are newly watching, please subscribe to my channel and don't forget to like, share with your friends. Thank you. Have a nice day.